Hey, I'm Helen Keller. And I'm Ann Frank. Today we're going to be talking about energy. So what do you think energy is, Helen? Well, Ann, why don't you give them the definition real quick, okay? I'll give them a little visual. Alright, well, energy is the ability to do work or produce heat. Yeah. What do you think energy is? Exactly that, you're putting in work, you know what I mean? And at the same time, there's heat between you guys. So just constant bumping grinds. Alright, so the energies we're going to be teaching you guys about today is thermal, chemical, potential, and kinetic energy. And an exothermic energy, temperature versus heat, and the structural formula for energy. Back to you at the studio, Mike. Basically, potential energy is energy due to the position or composition of an object, and kinetic energy is energy due to the motion of the object. So, yeah.
Yo, ayy, ooh, sticks out the window, bitch, yo, ayy, ooh, sticks out the window, ooh, sticks what I smoke in the wood, it's a stendo, ooh, sticks out the window.
Alright, you go, bro. Oh! You got a little 360 in! Alright, what?
Fuck it, dude. Oh, Josh, how does this relate to energy?
So, basically when Tanner was jumping off the bridge, as you could see, when he was loading up to jump, that was potential energy. And when he was in the air, flapping like a little bird, that was kinetic energy. Back to you, Bill.
So exo is releasing heat, guys, and endo is absorbing heat. So how it's all melting in your hand, right? That'd be endo. But since this is releasing right here, the candle, it'd be exo. So you guys understand?
Yeah.
Alright.
That's some good.
Thermal energy is the internal energy of an object due to the kinetic energy of its objects or molecules. For example, flame hits the pot or the pan, hits the water, boils it, convection. Science. I'm Helen Keller, and I will now be sending you back to Anne Frank in the laboratory. So this is the laws of thermodynamics, and it's also known as the law of conservation of energy. And so basically that means that energy cannot be created nor destroyed. And this little formula right here means that it's a change in energy equals heat plus work. So back to you, Helen.
What's up, my fellow capitalists? The second law states that energy tends to become more spread out.
Alright, so this is combustion reactions, and basically all combustion reactions contain a hydrocarbon plus oxygen. And so basically we have like an example right here, which is methane plus oxygen. Then it turns into carbon dioxide and water.
All combustion reactions are exothermic.
This is specific heat calculations, and for Q it's quality of heat, and for M it's mass in grams of sample.
And the C is the specific heat capacity, and then this little triangle T right here is the change in temperature. And then for short, it's Q equals MCAT.
Dude, what are you doing?
I seem to have lost my pants, but I wanted to let you know some stuff about enthalpy. It's the energy used or given off by a chemical reaction, and calorimeter is the device used to measure the heat of a chemical reaction. When there is a change in heat and it's positive, it is endothermic, and when there is a change in heat and it's negative, it's exothermic. Wow, that's amazing. Yeah, hey, can you hold the side with my pants back?
Yeah, sure.
Sorry. Rough day. Water. Alright. Class. Students, teachers, scholars, whatever you are. I'm Helen Keller, ironically. And you know, during this portion of the video, we're going to be talking about energy and fossil fuels and why that's important. So, what is an energy or a fossil fuel? I personally don't even know, but that's what the board's for. The sun is the primary source of energy on Earth. I knew that part. Sunlight is transferred to chemical bonds, potential energy, by plants through the process of photosynthesis. This is the source of energy for all food webs and all ecosystems, including agricultural, that feeds us. Also the source of energy that produces the chemical bonds found in fossil fuels. This. Petroleum and natural gas molecules store high potential energy in the form of chemical bonds between carbon atoms.
This is temperature versus heat.
Temperature is the average motion of particles measured in degrees Celsius.
Heat is energy flow due to a temp difference and is measured in joules. And a visual would be a bucket of water and a cup of water with both at 25 degrees Celsius. And if you induce 50,000 joules of heat into both of them, the bucket of water will become warm water and the cup of water will become hot water.
I'm Anne Frank, I'm Helen Keller, and we're signing off. Join us next time in our next video, picking up MILFs at the Galleria.